And if you have a question, ask me, and then I'll tell you. But I gave you a KSP, so you know something's insoluble. The question is, which thing is insoluble? And it says all chlorides are soluble except, and the three exceptions of the chlorides are what? Analytical group 1, silver, mercury 1, lead 2. So this has to be soluble. People gave you KSP for this. The other solubility rule says what? All nitrates containing compounds are soluble. There's a nitrate containing compound. So those two things are all soluble. I must have given you a KSP for a reason. There has to be something insoluble. And the thing that happens is this is going to react with this to make lead 2 chloride, which is the only insoluble possible compound you can get out of that system. So this is what you want to work with the equilibrium for. People work with equilibrium with this, with calcium ions, whatever. Now the next question basically it says, will a precipitate form? And there you want to calculate Q. I said maybe we should have really called it what? Capital P, because there's no quotient, or I use pi. But nobody uses that, and I just said that to be funny or whatever. Chemical jokes are weird. I have to explain them all the time. Because that's the way life goes. Okay, so basically, we wanted to calculate Q for this reaction. A couple of people calculated what? Oh, I'll tell you, because you don't see all the things I see. That is a reaction, but the K for this would be what? Because the SP reaction is always the solid going to the ions. So if you wanted to calculate Q for this reaction, which people did, you'd have to compare it to the reciprocal of KSP, not to the KSP itself. The easiest thing is just to work with the reaction you had, and this was when we introduced the KSP concept, and we talked about this. So all you have to do is calculate the concentration of the ions. Here's the chloride ion. There's 2 chlorides, so you have to remember to multiply it by 2. A lot of people forgot that. Most people got this one right. That's where people got their 1 or 2 points from. Okay. So now I have the ion concentrations. This is the final volume of solution. So all I do is plug it in the equilibrium expression. When I do that, I get 10 to the minus 7. This is 10 to the minus 5, so Q is less than K. And when Q is less than K, it has to go which way? To the product side. But several people did this, and then they said, yes, precipitate. If it's going that way, what's happening? The solid is dissolving. Precipitate isn't forming. If the Q were smaller than K, Q is bigger than K, we already had the smaller than K. If the Q is bigger than K, it says these numbers are too big, it has to go that way, now you're going to make precipitate. So the major, well, first of all, one of the big sources of error here was recognizing which is the insoluble substance. And this was basically from lab experiment 1. You should have looked at that right away and said, the only thing I can see is lead 2 chloride as being insoluble. Still not bright enough? I don't know. There is no other thing to make it brighter. Oh, let's try this.
Oh, there it goes.
Brighter?
Yeah,
Oh, look at that. Okay.
Perfect.
Now, if you read all those instructions and keep pushing buttons, something will work. Any questions about that? Okay, then we move to the next one. Darn, same old mistake. There it is again, 2 hydroxides. A lot of people had 12 point, I forget whether it was 4 or something like that. But you had to get 2 hydroxides, because what type of substance is this? Strong base. And again, problem with hydroxides, a lot of them are insoluble, but here's the clue again. I made a solution. I can't make a solution unless I could dissolve that much material. Okay. If I would have said 4.25 molar, then you could be justified in saying, can you really dissolve that much barium hydroxide? Barium hydroxide, remember the solubility rules, moderately soluble, strontium hydroxide, sparingly soluble, calcium hydroxide, slightly soluble, etc. So that came from the solubility rules in a sense. But basically, you just look at that and say that dissociated gave you 2 hydroxides. There's the hydroxide ion concentration. There's the POH converted to pH. Most people went from the hydroxide to the POH to the pH by doing that calculation. And you didn't have to show me 14 because it's only 3 points. If I see this and you say POH is that number, I'll believe you did this thing. What did you do to get that? That's how you got the POH, because P means take the negative log of whatever that number is. The biggest, well, it was only a couple people did this, a few people did things like this. When you're doing that sort of thing, what are you taking? The anti-log. That means you're going from pH to hydrogen ion concentration, or vice versa. That's really a nonsense calculation there, but that's one of the things I saw such people do. Not a lot. Most people got to this. Biggest mistake was respect. 2. Then the next thing is the buffer problem. Several people told me about this concentration, they told me about this concentration, and then they did the problem. And they picked either this number or this number. The other major mistake in here, a few people took this thing, it says, where is it, 0.155 molar. And by the way, the difference between the 2 versions of the quiz, all I did was interchange these 2 numbers. So if you're looking at the other version of the quiz, it would have been 0.35. But they did this. Now when you do that, you get nonsense, because you get what? Moles per liter squared. Notice here this said moles. So you did have to divide that by the liters to get molarity. But this one already gave you the molarity. Okay. So that was one of the mistakes I saw a lot of, where people divided this one, and then they divided this one. But this one is already in molar units. Okay. Then the next thing, of course, it is the buffer problem. And you have to work in molarities. You can't mix up the units here. Let's see. I guess here you could have multiplied by 0.225 and gotten moles. And then eventually you know the volume cancels out. But if you make one of them moles and the other some unknown substance, nothing's going to cancel out. So basically, you're doing this plus X, the C0 minus X. Doing the approximation then gives you hydrogen ion. A couple of people got this. I think I carried away. What did they do? I forget what that comes out to. But they did that step. But this, remember, we're talking about a case of A. This is an acid. This is its conjugate base. Okay. So once you get X, you do have the hydrogen ion. Subtract 14 because that gives you the hydroxide or the POH. questions along here? Because we're going to see these calculations again, and possibly again. We have an exam coming up, we have some more quizzes coming up, and we are talking about all these things. The last one. And again, in the lecture, I was talking about recognizing types of problems, and the three types of acid-base problems we have. And I call it simple. In other words, the only thing in the system is the weak acid or the weak base, and we did that problem a couple of quizzes ago, and most people had no trouble with that. That was the x squared over c0 minus x problem. Okay. Then the next type was that we got into a lecture. Buffer. That's what I just had on that quiz. Okay. And there you had to take into account the common ion, which is either the conjugate acid or the conjugate base, whichever it is. So that was, next time, I guess, what should I say? Weak acid, salt, weak base, salt, because there are two types of there's two types of buffer systems. The acid buffer system, where you start off with a weak acid, and the base buffer system. And again, you recognize all these things by Ka, Kb. And the salt contains the conjugate, whatever it is. In this case, if it's an acid, it contains the conjugate base. And I said, for purpose of calculation, and that was this question right here, you can forget about the word conjugate. You just know there's an acid and another source of the base in there. And this would contain what? The acid, which is the conjugate acid of that weak base. And then the third type of problem I talked about, salts. And these are made up of something that came from the acid, something that came from the base. And I said, the ones that come from strong acids and strong bases, you never have to worry about because they're too simple. If I have sodium chloride, what's the pH of that going to be? 7, because it doesn't affect the pH. If I have potassium hydroxide combined with HCl, KCl, again, no problem. So the salts we have to worry about, weak acid plus strong base. And you see this, and it tells you that the pH has to be basic for the solution. Oops, not less. Or we have strong acid. Then I told you about the weak acid, weak base case, and somebody remembered that and tossed it in. And what did I say when I talked about it? I said, I'm not really going to ask you about it. So I just tossed that in case you saw one of my really old quizzes. Because there are, we used to ask about that. It used to be covered in one of our textbooks in detail. I used to do the derivation for that formula, hydrogen ion is equal to square root of KWK over K over KB. And I said, I'm just tossing that in there for your general knowledge. Don't spend a lot of time on it.